Okay, this is some instruction on graphing linear inequalities. Very similar to graphing a linear equation, so this will be helpful in reviewing graphing linear equations, which we've been doing now. So graphing a linear inequality is going to not be a very big new thing here. So solving an inequality, here's an example of solving a multi-step inequality. We have been putting this straight into Desmos, and we would get this. X is greater than 7, so there'd be a line, a dotted line, in fact, and then the shading would be greater than 7. So that's how we solve. These are all the steps. They distributed, combined like terms, got the x's on one side, and came all the way down to the answer, the solution here. So you don't need to write anything in this area. Review of graphing a linear equation. If we had 2x plus y equals 4, this was in standard form. So y would be 4, and if you set 2x to equal 4, we'd solve for x and get x equals 2. So we could graph it that way. Remember the 2x plus y equals 4. Remember, standard form gives you 2 intercepts. And then y equals 4. So you could graph x is 2. Remember, that's the x-intercept. And y is 4. So that's the y-intercept. So we could draw a line through those 2 points. Okay. Another way of doing it is to solve for y. That gives us the slope and the y-intercept. Slope and the y-intercept. So if we subtract it 2x on both sides, y equals negative 2x plus 4. The slope, I want you to label it over here. So the slope is the number in front of x when y is by itself. The y-intercept is 4. So if we were to do that, we would come down 2 over 1, down 2 over 1, down 2 over 1. The advantage of graphing with slope-intercept, it gives you more points. Okay, so if you needed the y-intercept or some other points, using slope and y-intercept gives you more points. So these are the 2 ways I've taught you how to graph a linear equation. Standard form, get the x and y-intercepts. Slope-intercept form, solve for y, and get the slope, the number in front of x, and the y-intercept. We should be really good at graphing a linear equation at this point. Okay, so if you are, this next unit on linear inequalities is going to be fairly easy for you. So here's some keys to remember when you graph a linear inequality. Okay, 1, you're going to graph the inequality using slope and y-intercept. So you're solving for y first, exactly like you would do an equation, just like that, what we just did. The inequality symbols will tell you to draw a solid or a dashed line on the graph. Okay? And you must shade either above or below, okay, the line to represent the solution. So here is some reminders. If the symbol is greater than, it's going to be a dotted line. Remember, we had open dots, okay? And you shade above because it's greater than. Less than is a dotted line, and you shade below because it's less than. Greater than or equal is a solid line. That means any point on that line would also be included in the solution, and it's shaded above. Less than or equal is a solid line, and it's shaded below. So when it's not equal to, you have a dotted line, just like you used to have an open dot when we solved inequalities. When it's equal to, it would be solid line, just like we had closed dots. This was from before. Okay, so let's look at see how these look. We're going to do these together. So the first one is not solve for y. So how do we solve this for y? The first step, and you should be thinking about this with me as I do it with you. We subtract 2x on both sides. We get 3y is greater than negative 2x plus 3. Divide everything by 3 and you get y. We only divide it by a positive, so we keep the symbol. When you divide and multiply by a negative on both sides, you would flip the symbol. Plus 1. If you have any problems with solving for y, you have got to get that clear. So I graph my y-intercept. I do my slope down 2 over 3, down 2 over 3. I can get some the other way, up 2 to the left 3. Okay, so now I've got all these points. Now, we talked about this symbol is greater than. It does not include. So my line is dotted. It's going to be really important to use pencil too, because if you make a solid line, you're going to have to erase. So there is y is less than negative 2/3 x plus 1. However, the last part is to shade. I'm sorry, I said less than. It's greater than. So if it's greater than this boundary, we look at the y-intercept. What are the numbers that are greater than 1? Everything above. So we shade above. And this is enough shading right here. You do not have to color the whole thing. Right? That's good enough right there. Now, how could I check this? I could take any point in this shaded area. Let's look at this point right here to check it. And this point is 3, 3. Okay? I could plug this into the original. X is 3 and y is 3. And I'm going to put it right here to check it. Right? If x is 3 and y is 3, I'm checking this point in the shaded area. So 2 times 3 plus 3 times 3 is going to be greater than 3. So 6 plus 9 is greater than 3. 15 is greater than 3. It checks. That's the check part. Okay? That is the check part. You may be asked to check that, or you may be asked if a point is a part of the solution. There's infinite solutions here because this shading keeps going. Everything. Now, nothing on the dotted line would be a solution because it's dotted. Let's look at the next one. We solve this for y. We're going to add x to both sides, the inverse operation. X minus 8. Divide everything by 4. Y is less than. X over 4 is going to be 1/4 x. Negative 8 divided by 4 is negative 2. Okay? I graph my y-intercept first at negative 2. I do my slope. It's positive 1/4, so I'm going up 1 over 4. Up 1, let's go down 1 to the left 4. Solid or dotted line? It's dotted because this is going to be less than. So I'm making just dots here, or a little half broken line here. All right. And it's less than, so less than the y-intercept is down here. So I'm shading below the line. Okay. I can check. Remember I told you there's no point on this line that would be part of the solution because the line, the boundary is less than. So let's look at this point right here. And it's not going to be a solution. Watch. 4, negative 1. 4, negative 1 will not be a solution. If I plug in a 4 for the x, so I have negative 4 plus 4 times negative 1 is going to be less than negative 8. So negative 4 times negative 1 is negative 4, is less than negative 8. Negative 4 minus 4 is negative 8, and negative 8 is not less than negative 8. Okay? Had it been equal to, it would be okay. So this is not a solution, and we just checked that our boundary is correct. You could also, if you needed to, check any of these points down here to see if you shaded the right side or the correct side. All right, the next one. Solve for y. Subtract 2x on both sides. 5y is less than or equal to negative 2x plus 5. Divide everything by 5. Can you put these into Desmos? You sure can. But you also need to know how to do it this way as well. Okay, my y-intercept is positive 1. My slope is down 2 over 5. And we can go up 2 over 5. Now, my inequality symbol is less than or equal to. Is it dotted or solid? It is going to be solid because it equals. So any point on the line will also be a solution to this inequality. And it's less than or equal to, so I look at my y-intercept and I shade less than it, and it's everything below this line. Everything. There's many solutions to this linear inequality. Let's pick a point. Let's pick 1, negative 1. I like to pick easy numbers. 1, negative 1. I'm going to check this solution. 1, negative 1. I'm plugging it into the original equation. So 2 times 1 plus 5 times negative 1 is less than or equal to 5. 2 plus negative 5 is less than or equal to 5. 2 plus negative 5 is negative 3, and that is less than or equal to 5. It checks. That's how I can check my solution. Do you always have to check it? No. But it's good to know how to check it. And then the last one here, again, you are asking for help. If you do not understand any of this, it should be fairly simple. We need to practice it though. I'm going to add 2x to both sides. I have y is greater than or equal to 2x minus 2. My y-intercept is negative 2. My slope is 2. I start at negative 2 and I go up 2 over 1. And I can go the other way. Solid or dotted? It's solid because there's a line underneath, and it's greater than or equal to. So am I going to shade above or below the y-intercept? If it's greater than or equal to, I'm shading above. So above is up. I always start at the y-intercept because sometimes when the line is like halfway like this, it's hard to sometimes decipher what's above and what's below. This part would be below. Okay, it doesn't always mean it's negative or positive. We've got some negative and positive solutions here. All right, so that's solving a linear inequality. You guys are going to practice this a little bit, and then we're going to get right into systems of linear inequalities, which means we're going to be graphing 2 linear inequalities on a graph at the same time. We'll be doing that tomorrow or the next day.